Hi, all, this is Mr. Yeager for chemistry. We are looking at the last of the solution math, or maybe it's the first if this is what your teacher does first, is mass percent and volume percent. So this is just yet another way to show the concentration of the substance, of the solution, in addition to something like molarity. These would be another two possible concentration measures. We do see volume percent used if you buy any sort of like isopropyl alcohol, like for cuts and stuff on your hands and everything. They always usually say it's like 10% or even higher, probably higher. But whatever, you know, hydrogen peroxide and so forth, it usually tells you the volume percent that you actually have of that chemical in the water, in the solution itself. So we already mentioned what concentration was. It's the measured amount of substance dissolved contained in a particular amount of solvent. We're going to look at both of these, but they're very much related. Okay, one is mass and one's volume. So the two formulas do look very similar. It's just which unit you're using. So this is a unit of concentration expressed as the mass of the solute divided by the mass of the solution times 100. We do express it in terms of percentages because we are multiplying it by that 100. The big thing with this one that we have to be careful with is, again, reading the problem for context. You will need to combine the solute and solvent mass to get the full mass of the solution. Okay, so we do need to be very careful about that we do need to combine those two based on how the problem is worded. Okay, and so again, context, context, context. So here it is in actual formula form. Mass percent equals mass of solute over mass of solution times 100. The larger value, the more concentrated the solution. Basically, obviously, if you're 90%, well, obviously that's higher concentration than 10%. So, if we try a couple problems together, okay, it says we have a solution prepared by mixing 1 gram of ethanol and 100 grams of water. So, calculate the mass percent of the solution. So, mass percent, I'm going to change that color so it's a little bit easier for us to see. Mass percent, percent mass, is equal to mass of solute over mass of solution times 100. Okay? So, clearly the biggest mistake I run into is students will go 1 divided by 100 times 100. That's not correct. Okay? The ethanol is our solute, so that will be 1.00 grams on top, divided by the solution. The solution is the ethanol and the water together. 100 plus 1 is 101 grams. So you might be like, well, I'm only a little bit off because, you know, if we left it as 1 over 100, the answer is going to be 1%. You're going to be marked wrong because you're not including the solution as a whole. This is not solute over solvent. So 1 divided by 101, it comes out to times 100. It comes out to 0.990%, which is not 1, and therefore it would be marked wrong if you just said 1. All right? If you accidentally mess up the sig figs and round it to 1, you're going to be marked wrong completely. Like, we'll basically be like they don't know the math. Okay? So be very careful with this. All right, 135 grams of seawater is evaporated to dryness, leaving 4.73 grams of salt. Calculate the mass percent of solute in the original seawater. So again, context, context, context. Okay? My solute is the salt. I have 4.73 grams of salt. I have 135 grams of the seawater. Okay? 135 grams sample of seawater, that is the total amount. Okay, that is, I mean, what we are looking at with it. The amount, the 135 grams sample of seawater is evaporated to dryness, and you have 4.73 grams. This salt is already in the seawater, so we do not actually add it this time, and we just do this, 4.73 divided by 135 times 100. Because the seawater is already the solution. It didn't say it evaporated just the water. We're saying we have this sample, and we're letting it evaporate, and there's 4.73 grams out of the 135 left. So 4.73 divided by 135 times 100, I'm getting 3.50%. Okay. A certain lactose solution contains 4.5% by mass of lactose. Calculate the mass of lactose present in 175 gram of solution. So now we're rearranging this a little bit because we already are given the percentage. And we want to find the mass of lactose, which would be the solute. So I start with 4.5% equals, I'm solving for mass of lactose, so I'm just going to leave M up top. The solution, it says 175 grams times 100. Now, to me, I would tell my students just immediately, you can write this out, but if you're given a percentage, we always divide that by 100. We move the decimal point 2 times, and we're left with 0.045. Okay, equals M over 175. So we can kind of skip that step if you really wanted to. We can immediately go to this, where it's 0.045 equals M over 175. We then multiply the 175. And I get M is equal to 7.9 grams. Okay? So those are some different good examples of mass percent. I'm not going to keep on going with all of those. Volume percent, we're basically doing the same thing, except now we're using volume instead. So it's the exact same formula, just with volume. So we will have volume of the solute over the volume of the solvent. Or sorry, see, made a mistake already. Volume of solute over volume of the solution times 100. Okay, again, it's going to be a percentage. If I'm given the two parts of the solution, the solute and the solvent, I add them up together. So there's your equation. If you need to pause to write it down longer, do it. All right, so some examples. Basically, you're about to see the same thing. All right, determine the volume percent of a solution made by combining 25 milliliters of ethanol with enough water to produce 200 milliliters of solution. So again, context. This is your solute. This is your solution. So we don't have to add anything here. This would be 25 over 200 times 100. And that comes out to 13%. Again, it comes out to 12.5, but it's 2 sig figs, so 13%. What is the volume percentage of a solution formed by dissolving 75 milliliters of solute in 155 milliliters of solvent? Well, this one's as clear as you can get. Okay, I have my solute, I have my solvent. So this is going to be 75 of the solute over 75 plus 155. I need to add the two together, times 100 equals times 100. Sig figs, I got 3 and I got 4, so we're going to be 32.6%. One more. Okay, let's do one with it where they give you a percentage. There we go. So rubbing alcohol is sold at 70%, so I was incorrect. It's not 30. I was about to say that. I was like, I think it's a lot higher. 70% isopropyl alcohol in water. What volume of the alcohol is used to make 500 milliliters of the solution? So we're given the percentage, so 70.0% equals volume over 500 times 100. 70 divided by 100 times 500, and I get V is equal to 350 milliliters. Okay? You'd have to leave it that way. I know it's 3 sig figs, that goes down to 2. I would just leave it at that. So that's basically it. That is the last bit of the math, and you are good to go to practice and try to use all of them. Again, each one is very distinct, so hopefully there's not a lot of confusion with which formula to use. Obviously, percent mass, percent volume, they're very separate from each other, same formula, but different units. And the molarity is its own thing. Thank you very much.